Hi everyone, welcome back. Today we're doing sort the people. So for this question, we were given an array of strings names and an array heights that consists of distinct positive integers. Both arrays are of length n. And for each index, names and heights for that index denotes the name and height of that ith person. And we have to return names sorted in descending order by the people's heights. So tallest one first. So in the first example, we can see that the height of Mary is 180, John is 165, and Emma is 170. Similarly, in the second test case, Ali's height is 155, Bob is 185, and the second Bob is 150. So it's worth noting that it's possible for us to have names of different, like names that are duplicates of each other. So something to take note of. If we alias the length of names and heights to n, then n would be from 1 to 10 to the power of 3. That's really tall for people, but let's assume that that's true for this test case. For names, the length of names ranges from 1 to 20 characters, and the heights ranges from 1 to 10 to the power of 5. So I guess I misunderstood a little bit, but n was referring to the length, but it's still surprising that heights can be up to 10 to the power of 5. But let's take it with a pinch of salt. So that's pretty much it. One approach for this question can be such that we express the indexes of the original names as a series of indexes from 0 to n-1. So for example, let's call this integer of arrays. Let's call these names indexes. And this would range from, let's say, 0, 1, and 2 for this second test case over here. Let's use this second test case. So we can rearrange these names indexes by sorting these names indexes by height. So we can possibly define a custom sort function. We'll be using the sort function on the arrays collection, but we will pass in a custom comparator that takes that index that we have here and get the corresponding height and instead sort it by that height instead. And once done, the sorted names index will look something like this. So in this case, since Bob is the tallest, 1 will come first, and Alice is the second tallest, so 0 will come next, and finally 2. So something like this. And once we get the indexes, we can use these indexes to get their corresponding names. So sorted names would be the name at index 1. So in this case, this is Bob. The second is index 0, so that's Alice. And finally, Bob. So you can see that this corresponds with the output Bob, Alice, Bob. So the approach is simple, but personally for me, I found that the biggest challenge was, especially for me, because I come from the land of snakes. I'm a Python developer, so it was a little foreign to me. But hopefully this was a demonstration to describe the process. So the first step would be to define the names indexes like we described over here. And these names indexes would be a range of numbers from 0 to n-1. So to do that, let's define this as integers. And for our viewers who are sharp, you might notice that I'm using the box type of integer instead of the primitive integer. That's because later when we do Arrays.sort on it, we'll be using a custom comparator. And unfortunately, custom comparators don't work with unboxed integer types. So let's use integers for now. So this would be names indexes. And let's use a simple trick of using an IntStream. An IntStream, like its name suggests, is a stream that returns back primitive integers. We will convert this into a boxed integer in a bit. So for IntStream, it takes in a range function, and this range function specifies the start and the end of the stream. The first parameter is the start, and the second parameter is the end, and we'll pass in heights.length. Notice that we want this to iterate from 0 to n-1, but we are passing in n over here. That's because range function over here is exclusive of the n over here. So that's perfect. The next thing will be to box each of these integers from the stream into a box type. So to do that, we will call boxed on this function. And finally, this is an integer stream that's returning us back integers, but we want an array. So to do that, we'll do toArray. So unfortunately, if we call toArray over here, toArray will be confused. You'll be like, okay, you want me to convert it to an array, but what should the type of array in here should be? Right now, since we specify boxed, it's going to convert this to an array of object, but we define that this is an integer array. So to better refine the object type over here into an integer, let's specify integer of arrays, and we specify the new method under this integer array class. So this would successfully convert these names indexes into a range of integers inside an array. And to be specific, to be clear, names indexes would look something like this. So this is how it looks like under the hood. So let's move on. Now that we have the names indexes, we have to sort these name indexes with a custom sort function that takes every single integer in this in this integer array and get the heights for these corresponding indexes, and it will sort them accordingly. So to do that, we will do Arrays.sort. Arrays is Java util arrays, if you're curious. And in this case, we don't have to import it because Leetcode already imports it for us. But this sort function over here takes in two inputs. The first input is an array itself. So in this case, we'll pass in names indexes, pretty much the array that we want to sort by. The second argument is optional, but in this case, we have to pass it in because the second parameter is the comparator. So the comparator, like its name suggests, is an object of type comparator that specifies how the arrays should be sorted. And to be specific, its function compare will be used to sort the array. So let's create a comparator, and this comparator, since it's comparing integers, we'll pass in the generic type of integers, and we will call the constructor like this. Now the next step will be to override the compare function. And the compare function or method is more accurate because methods are functions under classes, but this function signature is public integer compare, and I will break it down the behavior of this compare function in a bit. So this compare function takes in two parameters, and these two parameters should correspond with an integer. So the first is an integer, and this is index 1. Index 1 represents the index on the left as you are comparing. Let's call this index left for better readability. So index left and index right. So imagine that Arrays.sort function is comparing two pairs of numbers side by side and deciding which one should go first. And it will sort them if like this compare function here returns a negative. So if it's negative, then what this means is that the left integer contains a value higher than expected, so it will flip them. So if you're curious, the compare function here is expected to return -1 for left larger than right, 0 for left equals to right, and 1 for in this case left less than right. So the sorting will happen when you do the swapping between left and right would occur if it is -1. So in this case, we have to specify a condition where the left index should have a smaller height than the index on the right in this case. So I guess it's for readability, but in a sense we can swap this. We can sort this later in a bit. So right now, let's do heights at index left less than heights at index right. So just like this, we have specified a comparator which returns a compare where the height of the left person should be shorter than the height of the right. But since we want this to be sorted descendingly, what we can do is we can invert it, and this would make us put the person who is taller on the left instead. So hopefully this is a good demonstration of how we can sort arrays by using a custom comparator. So now that we have sorted the names index, we can get something like this. So names index would look like 102. The next step will be to convert each of these indexes into names. So to do that, let's define sorted names. This will be a string array. Let's call this sorted names. And let's initialize this to a simple new string of size, heights, length. So we're initializing this array over here. So once we're done, we will do for int index equals to 0, index less than heights length, index plus plus. The next step will be to iterate through each of these names indexes. And for each of these indexes, we would replace sorted names with the name of this specific index. So now let's get the current index. This is an integer, a boxed integer. Current index equals to names index at index. So the next step will be to get the corresponding current name. This would be names at current index. And now we can set sorted names at this index to be equals to current name and return sorted names. So that was a lot of detail, but to make it clearer what is happening, I'll be tracing this approach out so that you can see how each of the variables change as we use this algorithm. So the first step is very simple. We will return 0, 1, 2. This is an integer stream. We box the type so that each of these integers over here are converted from a primitive integer to a boxed integer. And the next step will be to convert this integer stream of integers into an array, where the type is a boxed integer and it is an array type as well. So once done, we will use Arrays.sort on Java util arrays. We will pass in the names indexes that we want to sort, and we use a custom comparator over here to sort them such that the people who are taller are on the left first. And once we are done, the names indexes will look something like this: 1, 0, 2, where 1 corresponds to the person who is the tallest, Bob, 0 corresponds to the second tallest person, Alice, and finally index 2, which pointing to the shorter Bob. So now we are going to convert these names indexes into names. So what we did is we defined a similar string array that is of the same length, and we proceed to get the index from each of these names indexes. We use this index to get the name, and we populate it in sorted names, and finally return it. So just to make it clearer, you can see that index is equals to 0, and you can see that current index is equals to names index at 0. Names index at 0 will give you 0. Oh, sorry, in this case it's 1. This index over here. And using this index, we will do current name equals to names at index 1, and this will give us Bob. So we will put Bob at the first position. So let me show you how sorted name will look like. So sorted names, you can think of it as having null values right now, like this, and we have just replaced the first index, sorted names, 0 equals to Bob. So we put Bob here. Let's move on to index 1. In this case, names index at 1, in this case would be 0, and names at 0 is, Alice. So this is Alice, and we will populate sorted names 1 with Alice. And you can see where this is going. The final one will be Bob. So hopefully this trace is clear. Let's check to be sure all the semicolons are there as usual. And looks great. Let's run this code. So I forgot the return statement here actually. Yes, because compare returns an integer. And I forgot the semicolon there. It's embarrassing. But let's run this again. Boolean cannot be converted to type integer. So let's do this instead. And cannot find symbol. Oh, that's interesting. Why didn't this get commented? Interesting. Okay. That's weird. Okay. And one thing that I could have done better is, instead of doing this might overflow sometimes. If you have a very negative number here and you take this number and you subtract it by a very negative number, this will be potentially giving us an integer overflow. So instead of doing that, we can use integer.compare, and just like this. So since we want, the compare over here will return 0, -1, or 1, just like this. And in this case, because we want the left to be the one with the higher height, so we can put a negative in front, and this would put the one that is taller on the left side instead. So let's run this again. I'm curious that, yeah, this is curious. Why is it that it is complaining about this comment over here? But okay, I will just remove these traces. Hopefully that didn't confuse it. Looks like this is fine. Let's run this again. Error, cannot find symbol at names index. Ah, okay, it's not names indexes, sorry. That's really embarrassing, but it's okay. So this passes. Hopefully this wasn't too confusing. There's a lot of details here, but I hope that this is a good demonstration for how you can create your own integer arrays using an integer stream. So, and we also show how we can sort an array by using a custom comparator. So I found these details very helpful personally, so I hope this is very helpful for you. Let's run this and submit this code, and you can see that this passes. So now let's get into the time and space complexity. So time complexity. So if we let n to be the number of names and heights, they are the same. In this case, we will be taking on time to create this stream. So this stream over here is lazy. So it creates an object that is a lazy iterator, and it's not evaluated until we call toArray on it. So by calling toArray on it, it's going to create a list that is of the same size as heights or names. So understandably, to create an integer array of the same size is going to take on time. Now the next step is to sort based on the indexes. So in this comparator, it takes O1 time to get the height for index left, O1 time to get the height of index right. So this is O1 pretty much doing the comparison. But the sorting itself is going to take O(n) log n. And in this case, this is going to be very expensive. The next step is to iterate through all of the sorted indexes to replace them with names. So in this case, it's also going to be O(n) as well. It's very expensive, but as you can see, the time complexity of this approach is O(n) log n plus 2n. And if we remove the bases, if we remove the lower bases and keep only the higher bases, this time complexity is n log n. Now let's look at the space complexity. So let's remove all the workings for the time complexity to remove confusion, and let's take a look at this. So this is going to take O(n), because we're using up to O(n) space to store a copy of all the names indexes. Afterwards, sorting doesn't take any additional memory here. I mean, it does, but it's constant time. And in this case, we are going to use another O(n) over here to store the sorted names, and we don't really use any more memory here. I mean, just a few for temporary variables here, and that's pretty much it. So in summary, we use O(n) space complexity, but if you remove the bases, the space complexity is going to be O(n). So that's pretty much it. I personally found this question as a beginner deceptively hard, more because I'm not used to the techniques used to recreate an integer array and stuff. But I hope that this was useful. If you like this, please give us a like and subscribe, and we will see you in the next video.